need to get this as close to the edge here.
Yeah.
No, you want to hold this close. Don't worry about it.
Okay.
I coming down on it. But I want to get this close here because it's real tight.
Right.
As close to the end, eh?
Yep.
Perfect.
Now a little more. Swing it. No, stop.
Uh-huh.
Pull that a little so.
No.
That is kissing, but it's not kissing it. Yeah.
Alright, yeah.
Right in. Good.
Alright.
Right.
It'll drop into place.
Yeah. Because they have a little bevel there too, that helping out. Yeah. Lovely, man. Yeah, good job on this trolley. Don't worry about them wheels, boy.
Nah, that means it.
Right, this can't go back any further.
Okay.
What do you think it weighs?
I have no idea.
1,000 pounds?
Yeah. Coming back. Yeah.
Today's adventure. All right, folks, what we have here is a new tool for my workshop. A new machine. It's pretty big. And, I mean, it's not that much bigger than my other stuff, but it's heavy. This is a metal cutting lathe, right? And that is a machine designed to cut round or cylindrical objects via the spinning of this and dragging cutting bits along the side of the raw material. It's a very much a piece of precision equipment, a very fine engineering. And from my little bit of research, this may be as old as from the World War II era. Some of these machines were like a portable machine used during World War II. So this has obviously not been used in a long time. Some things I'm trying to turn are not turning. And, what this needs is to be clean, painted, lubricated, and to make sure that that it gets running again. These things don't really go bad. They're too heavy. They're too strong to break. Right? All you have to do is get the motor running, and the whole thing should work. Right? But of course, it has to be clean and lubricated and so on, so that it operates with precision. Right? Well, I just could tell my grandfather is looking down at me, right, while examining this thing. It smells of his workshop and his garage, right? So this thing needs to be clean. It's obviously not been used in a very long time. It needs to be lubricated, cleaned, painted, and adjusted back into operation. It should be very precise. This is a precision machine, and a lot of work needs to be done to get it running and adjusted properly. All right. Just the smell of this thing is my grandfather's garage. He used to have a lot of old cocoa machinery we used to play with as kids. It wasn't in use. It was just old salvage parked up. It had all these wheels and levers and all motors all over the place. Just reminds me of that. Okay, so this is just exactly as I got it. I haven't started to clean or lubricate anything. There's things that I want to move around and they're not moving. I just got this to move a little bit, but this isn't moving. This will turn. This I just opened up, and I can move this. Put a little WD-40. This moves. This turns. But it's again down here. It's not engaged to the lead screw. How do I do that? It's leaning at an angle here. How is this supposed to be engaging the lead screw? I don't know. This moves a little bit, but it seems stuck in one setting. This can be moved, but it's very stiff. It seems to need this to turn while this doesn't move. This started moving yesterday. This kind of unlocked, but now no matter which way I turn it, it doesn't seem to lock back and stiffen back up. This moves a bit and does move the carriage, but it just takes quite a lot of force. It's not moving easily, right? This is completely stiff. This will move between two settings. This I haven't really tackled yet. This I can do this, but I can't get it to gear over to the right side. This moves, but again, I don't know what I'm doing. I haven't learned anything yet. So if people could kind of guide me, and I would like to put up a picture of this, and maybe people could put a label on each control on what it's supposed to do, which way it should move. That'd be really cool. I'm going to start just hitting everything with WD-40 and let them get soaked in a bit. Another question is about this, which I believe is the compound top slide, right? So we have this wheel here, we have this wheel here, but this one doesn't have a wheel to turn. I guess it can be turned just by this grip here, this knurled grip. But right now it's very stiff, of course. But is this something that could be retrofitted to have a feed handle like this? Right? Because I find this seems really awkward. You wouldn't really be able to move this forward smoothly. Okay folks, I'm very pleased with myself. I'm back on lathe project this evening, and most of the parts of this lathe that was seized up, everything was seized up, nothing was moving. And now I've gotten everything to move as it should. Right? All this stuff, all these gears and things over here, right? The last thing that wasn't working was this gearbox, which selects 9 different gear ratios, which you could count on these holes here, which changes the ratio of the speed on this side to the speed of this shaft here. It's not rusty, it's just so much old grease. Everything was stiff. I figured out exactly where to hit it with the hammer on the side that I could get this to shift. And I have to make a comment. I'm often complaining about new versus old in manufacturing technology and consumer products. Like I'll have an old amplifier that's 40, 50, 60 years old, and it still has good metal work. It has, the chrome is still there and it's still shiny, and the nickel plating is still there and it's still shiny, right? And nowadays you buy a guitar or whatever, or cars or whatever, and any kind of metal shiny surface is rusty within a couple of years. Look at this thing. This thing is 80 years old, right? And there's actually no rust on this machine. What you see as brown and black and dark stuff is just blemishes and old grease caked on, but all the metal work in this gearbox is still actually perfectly good and rust free. So really it's just a matter of loosening things up. But let's just look inside it because it's cool, right? So you have a whole bunch of gears here, and this, you pull and push on this to make different gear ratios, but ultimately you're turning this shaft, and this shaft comes in here, and that's the horizontal shaft there, okay? And this lever slides along that shaft, and what it does is there's a gear in there. You can see it turning, right? And that gear spins this whole stack of gears down here. See? Whole stack. And they're each a different size. You'll notice as we go from here headed to the left, they're all bigger. Okay, so each different size gear, different amount of teeth. We'll have another discussion on that. Different amount of teeth gives a different ratio. And this unlocks one gear at a time and clicks into whichever one you choose. And it'll kind of snap into place. And as you slide it across, there's a mechanism in here with a little ball bearing on the tip. A ball bearing behind a spring. Right? And the spring will push. See that there? Well, not a ball bearing, but a shaft. There's a spring behind it. You can see it like that. Okay. And when we get to each correct gear, there's a hole that shaft will fit in. It's hard to do while holding a camera. And it will lock into a particular gear set. Okay? So I just think it's really nice to look down in here and see all that stuff happening. And there's another lever here. This one changes the ratio as well. Look at this. It's from that to that. Alright folks, back on the lathe project, not for too long this morning. The final piece out of all of these that I have not been able to loosen up or get working or unstick is this thing here. This is called the tailstock and the quill. This is effectively a clamp that pushes a piece of work against the other section that does the main clamping here, right? So it will hold. So when something is turning, it's turning between this spinning chuck and that pointy edge. But this pointy edge here is useless to me. There's more modern ones that are sharp and they spin on a ball bearing. This one spins, this one stays stationary. So this piece in the middle is rubbish to me, right? So I have not been able to get this out of here. It's quite long and it's stuck probably with a little bit of rust down inside this hollow center here. So I have to get this out today. The usual oils and WD-40 and so on has not, and pounding really hard on the inside there with a shaft hasn't worked. My last resort is to heat this area that I'm holding. Hopefully it will expand enough that this could pop out or be hammered out. So how am I going to heat that? I don't have a blowtorch. I don't have a heat gun. So for now, that might do the job. Wow, folks, and here we go. I heated this with the iron. As you saw, I dunked it in cold water and heated it again. And that's when it finally cycled the expansion and contraction enough to break this bond. This would have been held together with however many years of this crusty rust and dried grease. And I'm throwing this in the garbage bin, but this piece is vital to the lathe, right? So I needed to preserve this in good shape. So this receives other tools that have this taper on it, which lets them fit securely inside that hole. But there's much more modern stuff. This is completely worn out and useless and outdated. Folks, I'm having a little bit of a Breaking Bad moment, a little workshop mistake. So I've been putting in a bucket down here. I've been putting a plastic bucket. I've been putting a phosphoric acid, which is a rust eater that I've been dipping parts in, right? And yesterday I poured out a whole bunch of excess of it into this metal can, right, without thinking too hard. And guess what? Overnight, the acid has eaten through, well, it's done its job. It's eaten through the metal and the rust on the inside of the can and started to leak and drip out. And again, it's a Breaking Bad moment. If you're a Breaking Bad fan, you know exactly what I'm talking about. When the bathtub falls through the people's ceiling. All right, so I've hooked up everything. You know, I forget how smart I am sometimes. I thought I had to drag this whole assembly outside to my 220 hookups to plug it in, and I realized I had an extension built in right here behind my CNC machine. Anyway, so this is hooked up. Everything plugged in. These two are directly connected to each other, and I'm switching on. And that is spinning. Problem is the motor is kind of making a loud squeal. So it probably needs some kind of overhaul and re-lubrication. And we're getting our meters to light up as well. This is the reverse direction. Well, this finally worked. I put a piece of pine in between this ring gear and the housing, and I chucked up this piece of 2x2, and I finally got a chuck to start moving. So thanks for the help, guys. All right, folks, I've finally done enough prep work that I can start to stir up the paint cans and get ready to paint this lathe, right? I've done angle grinding, wire wheel all the way around, gotten off all the original paints. Maybe it's lead paint or something, who knows. But it was all messy. It was several layers of paint actually. And I've masked off certain areas I want to remain raw metal or finish some other color later, the handles and stuff. And on the waves, and I'm going to start spraying on an epoxy white enamel. It's actually this Rust-Oleum here, which I hope holds up. It should be good. I see good reviews online, but in the context of a lathe, it'll be a pretty hard life for any kind of paint. Alright folks, all of my homework is done for the day on guitar stuff. So now I get to spend some time tonight, a couple hours I'm sure, fixing up this lathe again. So it's taken really long to prepare this for paint because it was so covered with dirt and grease and so on. And now I have to try even remember what parts I took off, what I've done with them. Some I've painted, some I've just cleaned off and have sitting in bags and so on. So I have to figure out now the putting back together of everything. And there's certain areas that I did not paint because there's so much wear and tear on them, there's no sense painting them. But you don't want to leave metal raw in this case. It could pick up some rust and so on. And you don't want to put oil on everything. So I have a bit of an in-between solution to that. Oil on any metal surface is great for keeping it in good shape, free from any rust accumulation and so on. But I will be cutting wooden items on this lathe as well. And the wood dust and so on will stick to an oily surface. So I actually want to minimize my oily surfaces. And I'm going to be using wax, paste wax, because a wax surface will completely seal the surface from oxygen, prevent rust and so on. And these kinds of things, these things that you bare areas that you're using all the time, it will keep any type of dust and wood dust from sticking to the surface, but it will also have that kind of dry, non-sticky, invisible coating. So that's the order of business tonight. Wax cleaning of some little paints, just trimming some paint work and so on. Cleaning and waxing certain surfaces. Then oiling and assembling other parts. Right, this is going to get filled with oil. I'm actually not even sure how much oil I have to put in this, because I tried to ask online for help, but no one really had an answer for me. I have a whole bucket of oil over there, and this should be full about halfway. When I'm done all of that, we'll get to the motor and stuff that I've shown you all, control box and so on. Anyway, I get to peck away at this bit by bit. Should be a couple of days before it's fully running. Maybe tomorrow will be fully running, hopefully. Okay, so the fun, or one of the fun parts begins again, which is just to take all these old parts and like working on your car, working on your bicycle back in the day. Just trying to remember where to fit everything back together and put each piece together carefully with oil and so on. So it's fun doing this stuff. It's like building a Lego set. The pieces are already there, you just have to see how they go together. You have all these fun specialty pieces to go together. There's a piece of brass goes in the top here. While holding that up, I have to slip this in here. It's fit together a certain way. Right. Then this piece has to go. Gets this. Let me tell you, I spent a lot of time taking this apart. So much that putting it together is quite a breeze now. This goes here, and then this goes in the back section. While I'm screwing it in from the back, it screws in to this at the front. Okay, things are getting a bit odd here. So I notice if I fill the oil probably to its correct level, then oil comes gushing out of this shaft. This fitting is normally on here, right? But oil is just making its way through that gap, right? There's quite a gap between this inner part of this ring and this outer part there. There's quite a space, right? 1/10 of an inch space all the way around, right? So clearly this is where rubber, I checked the diagrams for this, and it's supposed to be a rubber seal on the inside here, which has completely disappeared. So I have to now find one or make one. There's an odd fitting here. This groove here, the black line, is meant to actually hold the seal in place. So it's probably not something that I can just go out and buy, in a car parts store or anything. So I'm going to actually try and make a seal for this now on the CNC machine. Right, so I've been taking several measurements here. The inside of this circle, the outside of this circle, the width of this groove, how far it goes across. And I'm going to draw those on my CNC program. I'm going to try and cut it into this material. I think this is the best choice. If it doesn't work, we could try a few other materials, but this is a good place to start. Right, let's get over to the computer now. Alright, so sometime drawing here, after doing all those measurements, and we go over and we can do a simulation of this seal, and this is pretty much what I think we need here, right? And I'm going to cut that in that red material. And let's see how it goes. May not be right the first time, but it should be pretty good. Right, so I've removed this. This is the seal that I've made. Look at that. Let's see if it fits. Right, so here we have this polyurethane rubber seal. Oh, I could not buy this anywhere. It's not sitting down in any shop waiting for me to buy it. It's not the cleanest cut. If I was moving a bit slower on the machine, I guess it could have been cleaner. I've cleaned off the dust on the edges. You can see there's little grooves left by the cutting. I think that's going to actually help us in the roller forming a seal. So I'm going to squeeze this onto here and let's see how it fits and if it works eventually. Step by step, one thing at a time. All right, I'm going to fit this thing in. There's actually a little screw right here, this black thing, which is meant to lock this flap in place when it's in. So I have to kind of get it on facing inward. I'm getting it into this groove here. Should fit. It's I just want to get it in without tearing anything. Yep. Okay, I'm press fitting this into place, and I can see this part of this flap hits the shaft. So I'm just going to cut this off, because if I don't cut that off, it's never going to sit down there properly. Okay. Right, now we attempt to fit it properly. I really hope this works, to be honest. It'd be awesome if we just build these again anytime they go bad. Right, so that fits in there. And let's see if it continues to fit when I slide the rest of it together. I have to put this lock screw in here, and then put this on there. Alright, well we have a bit of a fail because this fits in here very well. But the way I cut it, I put a little too much diameter on the outside so that it would be able to kind of compress in place. But it's too big, so no matter how much I push this on, I'm not going to get it to fit on smoothly. This lip here is just pushing against this on the inside. It's not slipping over it. So I'm measuring the error basically, like that is 5.6. Our error, the difference in size is about, how much? 0.6 of a millimeter, which is significant, you know, if you're trying to compress something that's a tight fit. So I need to reduce the diameter that much. I'll redraw it so that it cuts that much smaller than it is now. Or maybe a little, maybe like that much smaller. Fit like 50, you know? Right, so it's only that much narrower than it should be. So I'm gonna reduce it, this outer circle there, I'm gonna reduce it a bit. I'm gonna go 50. I still want some compression. Right. Okay, so the one on top is slightly narrower. Let me just trim the edges a bit and put it on. Okay, that finally actually went in. I've given it a few turns, but we don't really know how well it's working until it's full of oil. So that's the job. I'm going to continue with my oiling of the machine and hope that things continue to go well. Okay, so I'm getting ready to fit this motor, which we've looked at, and this control box, which you've seen me build from scratch. And I'm going to add one little modification to it before putting it on the lathe machine, because I have to hook up all these wires. I have some adapter plates I've made here to connect everything together physically. But the thing is that we have this sensor which has to go in the back of the lathe, and it's just hanging out here with the rest of the big electrical wires. And it has to go to a very sensitive bracketing area to pick up the rotation of the machine. And I kind of want the connection out of the way, so I'm going to put on a microphone style connector that can be removed anytime. Okay, so I've drilled and wired up and generally installed a few more fittings tonight. Not everything. I'm still waiting on some switches for the front. I haven't gotten those yet. But I'm doing this connector here. I decided to do a removable connector for the sensor. In case I ever wanted to do something and if I'm taking apart this part of it, I can disconnect the sensor from its sensitive installation, etc., etc. So I use this type of connector, which is actually an audio connector. This is like a microphone. The audio guys would know this is like a microphone XLR cable, right? And what's good about it is that it keeps the different pins. They never touch each other when you plugging in or out. Those pins don't touch each other, and voltage doesn't go where it's not supposed to go. I could have wired this up the same socket and plug thing with a XLR guitar type connector like this, right? But in this case, let's say I put ground here and 5 volts here, 12 volts here, and then the signal on this middle one, right? If I were to plug in while the units was on, 5 volts would hit the ground and short out. 12 volts would hit the ground and short out on its way, and that's called hot switching. We try to avoid that, especially with guitar pedal setups. You don't want to use the little headphones style power connectors, right? Which does come on some older pedals, DODs and MXRs. You want to get rid of those, because if you plug in or out while everything's on, you will short out your power supply. One last tidbit of information for now. You see the label on this casting, it says Canon, right? A Canon XLR connector. Now Canon is the original company. James Canon, back 100 years ago, started making connectors for the movie industry, audio and so on. When audio first started, was in the movie business, right? And the connectors he made became the industry standards, and many people, we call these XLRs here in Trinidad, definitely, but a lot of places and around the world they call these microphone connector a Canon connector, right? The name has stuck. The Trinis already use that word, right? So That's it for now. I've done all the metal drilling here to mount up everything. When all the electrical stuff is done, we mount this on the lathe, and right up on top of it. So again, just to wrap up for now, this is a sensor that will detect how fast and how many times the lathe turns, and the other end of it will plug into the control box, and I can remove it and attach it anytime I want. Right? Hold on, let's do that one-handed. And also too, these microphone connectors, they have a locking mechanism, so I really can't pull that out until I push that tab in there. So it's very, very secure. Okay, electrically and physically. Right, so I'm done with that for now. Thank you very much. Here is the motor mounted up. That's where it's supposed to be. And this is the new control box. So you can see it's in a nice, convenient location. It's in line with all the rest of the controls. Right? And right in front of the motor, leaving some space between it because this motor is going to get hot. So it'd be nice to leave a little bit of an air gap here. And that's it. Soon, I'm just going to work on this. So I'm going to have it up running very soon. Right, and now I have these pulleys installed, motor drive and machine drive, and make sure and put them on the shafts so that placing a ruler along them, you have an exact linear path, exactly parallel and level with each other. Okay, so the next thing I'll do is put on a belt and fire that up. Okay, so now I have put on this this red link belt. This may need a little more tightening. This is made up, this is a modern type of belt. Instead of one black rubber belt, these are made up of these heavy canvas style pieces, and therefore you can make a belt any size you want and adjust it. If it's too tight or too loose, you could just remove or add one or two of these individual pieces, and you can just make any size belt you want, and they're pretty good. Right, so I've also done the wiring. I've run a wire to the 240 volt socket down there, and I'm ready to start. That's all there is to it. I have on some eye protection in case anything weird happens. Right, switch on. Alright, so I'm switching on. I've noticed though that there's the digit here, the current meter, doesn't seem to be coming on properly. The sensor for that is giving some kind of problems. The wire needs a little bit of jiggling on, but something up with that ammeter. There you see? Something's wacky with that. Anyway, so we are running here, and the next thing to do is engage the gears to actually run the machine, but that should be done while it's stopped. So I'll stop and restart that. Okay, let's see how it goes. This is turning. Moving slowly that way. Now, I've mentioned earlier that there's so many different speeds that can be had from the different settings, right? So I'm not really even tracking right now what speed everything is moving at. But another example, if I switch it on now, all this turning, and this all drives that screw turning there, which drives this carriage. And I've reversed it on one of the levers here. I reversed it so that it's going that way instead of this way. And I can engage the switch. So this will hold cutting tools, cutting bits against the workpiece. And if I want to automate it moving that way, I hit this switch here. And you can see this is now turning. These both turning at the same time, right? This actually produces a diagonal cut where it's moving in and down at the same time. And if I want to go move this that way or that way without this moving, I just release this. This will go that way. Of course, it's moving very slow because that's the ratios that it's set at right now. And generally, the movement of this will be slow. But let's see this. If I stop this and I want to come back, this is going clockwise. Let's say I want to go anti-clockwise, right? Switch off here. Switch one of those levers down here. Switch back on. It's now going anti-clockwise. So I will be moving back this way. So I've been learning all the controls, what all the little levers and switches do, right? If I engage this now will come back this way. So I do that, yeah? And it's now headed back in this direction. And again, all of these things could have the speed varied. Okay, I've just realized from this table here, I have this set on the slowest setting. And let's crank it up. So right, so on the slow setting, you can see how slowly this moves. Okay? And as a result, everything else down here is taken off of that slow speed. So let's rev it up and see what happens. Right, so find this belt is stretching and it's not really catching on. That's weird. Yeah, that belt's not happening. That's actually the second highest speed. It won't drive the highest speed. That belt needs to tighten. Look, I'm seeing some oil leaks starting here. There's a little bit, but that's something I could deal with. Alright, so I got it up to the second highest speed. Not bad. Right, so we immediately see some fine tuning to be done, and that's no problem. That's how everything goes, right? Especially after this kind of overhaul. And again, decades of not being used and new parts being added. Like this, only on the highest speed setting, this is not able to, this is really hard to turn, right, at that highest setting. So this, I think, is a combination of the brand new belt, which still has to do some stretching, so it's kind of getting looser every minute that it's being used. And also too, these pulleys are brand new, so inside here the metal is very shiny and smooth. Right, so we have new plastic here, new steel surface here. I think rubbing a bit of sandpaper on the insides here will help a lot, and then letting this belt continue to stretch will cure that problem. All right, again, this is just a little experience with those things that can be improved greatly. Okay, I've just done the full setup on this of adding in this sensor that reads how fast this turns. There's a magnet glued on. And every time that magnet passes this sensor, it counts 1 on this screen. Also determines how fast it's rotating and determines an RPM, how many turns per minute here. fix the belt slipping issues. Right now, I've oiled up everything. It's perfectly running here. But I found out that everything is running a bit fast. This motor driving this haze is going too fast overall. That means I'm kind of off on my pulley sizes. If I don't have the original pulley sizes correct, we could be off. If this was bigger, the machine would run slower. Or if this was smaller, the machine would run slower. So our ratio is a little off. Right now, this should be 26, and let's see what we get in. 41. Right. So many times it spins there. Now that's not bad. We know the RPM, it's read out there. So even though we have these charts saying what the RPM should be, even though we're off, at least we know what we are actually running. Now I don't mind it being a bit fast because I intend to do some wood cutting projects on this anyway, and you need more speed to do wood cutting. Okay, so that's not a problem. And I don't even think it's worth changing these and playing the guessing game until I get those speeds accurate. Let's try the fastest setting and see what we get up to. The fastest setting on this says 620. Let's see what we get up to. I just move these levers. Shit, that's slipping again. See? Fuck. Right, so I'm actually really happy about this speed setting. I'm going to leave it alone because if lowest speed of 40, that's fine. I'm never really going to do anything that slow. And the high speed of 1000 is pretty much just what I wanted for woodworking. That's a good speed. So I'm going to leave those as is, and I'm happy with it here. All right, so we're doing a little side quest here today. We're back on Mr. Chips, and we're building a few pieces in metal. I have some scrap aluminum here. Well, this was a piece for a router that I'm not going to be using anymore. So scrap aluminum, and I'm making a couple of metal tools, aluminum tools, for the new lathe machine, right? Because there's a couple of bits and pieces that are missing, or it would be convenient to have, you know, a custom-made metal wrench, basically, right? So I am just setting up on this with the stuff that I've drawn, and we're gonna start to come up with, you know, we'll set a procedure here to start cutting into this metal here. I have done some cutting in metal, but it was really just pretty reasonably thin aluminum and engraving letters, right? And that's all gone fine. Well, some of it has gone fine. But this bit, very, very sharp little bit is the right style to tackle this. Even though it's very small, it's the right style to tackle this thick aluminum, right? So hopefully that goes well, because it will increase my capacity and ability a lot if I'm able to cut metals that are up to about that thickness. It'd be very useful. So I hope this goes well. I may break the bits, but Right, so from that metal plate, I have formed and finished off a series of metal objects. First one on the right, this is an everyday wrench with this very big hex hole here, and it's an everyday wrench for this this nut, which has to be turned very often. You don't want to have to use a big giant one, right? So it's a nice short one. This plate is a modification for this wheel here. I'll be adding, this does not have a little finger piece like this and this, right? This one, you cannot turn this smoothly without such a finger piece. So this is going to be for adding one on, right? This here, we know that this lever is broken. It's cast iron. It's going to be difficult to weld. I've made this piece, and this I'm going to shape and form a bit more to grip around the stump of this gear and be able to turn it easily, just as this one here. And finally, over here we have a name plate, because like we named our lathe Mr. Chips, this guy is going to be known as Uncle Albert, right? Because two people came to mind while I was working on this machine, right? My grandfather, who had all this kind of shit hanging around his house, and old Uncle Albert, for a friend of my grandfather's, who my other grandfather was one of the pioneers of the local woodwork industry, right? So I'm still waiting on a couple of tools to really run this properly, but the physical restoration of this is pretty much complete. Okay, so a productive evening so far, afternoon. And the purpose of that grinding and carrying on was that this whole kit of stuff that I just have been talking about came with this rectangular piece of metal. Was a much larger square block, and it's meant to be cut down to fit a particular machine. So the cutting and grinding just so that this could fit into that slot there. Okay, and having done that, we have this pole inserted into it. And onto that goes this big heavy block here, which is the whole tool holder mechanism. And this thing here will get fit sturdy into place, but what it does is these other fittings that hold the cutting tools drop into place on this. Understood. Alright folks, I've slowly been working my way towards this, which is using this lathe machine for the first time. I got on Friday, I think, some new tool holders, basically hold cutting bits, and I got this bit holder here, and I've adjusted it over the weekend. This bit, the tip of this has to be exact same height as that tip there. And I'm just going to try it literally for the first time. Of course, I've not been in any rush. I've been really taking my time to set things up. And I've just taken a piece of pipe, like a kind of galvanized plumbing pipe you would find in the hardware. And there's a couple of pieces I just had that were cut up for some old previous projects, and they were kind of roughly cut. So the first exercise on this one is just to sort of recut neatly and just mess around with this piece here. Just try a few little things on it. can see I've started to shave off metal as it spins around, right? Okay, so my memory card filled up a bit, so I just lost some stuff there, but so this is the rough exterior of the original pipe, and the shiny part is where I've been cutting into, right? So we'll cut another layer just a bit deeper until it's shiny all the way around, right? We're just looking to clean up that edge, a rough edge that was cut with grinders or something very rough. That's a proper cut there. Right, so what I just did there was a real proper cut, because you can see these are the flakes that came off. So those are pieces of metal coming from all the way around the circumference of the pipe. Right, so these are proper deep cuts, right? So I've shaved down all this shiny section here. And let's trim off this edge here so that it's all perfectly flat and level all the way around. It's not bumpy and rough anymore. Right, so now we have this whole outer rim has been shaved clean, and also this entire end, this entire face here has been completely it's freshly routed cut metal, you know. Right, so let's have a look at the end of it. Right, so that's my first operation. Okay, I didn't clean up the inside edge. You can still see this leftover metal shavings and stuff, right? Because I would have had to change tools to clean up the inside. I'm really just doing one simple operation. So we took a little pipe like this with a rough, rusty, rough cut edge, and made a very clean, perfect edge, right? And of course, if I wanted to, I could have continued making this whole thing shiny, skimming the whole surface. Or I could change the diameter of it to a particular diameter that I want. Or I could even, well, when I get a bit further into this, I could actually thread the inside or outside, like how that looks in there. But we're a little bit away from that still. Right, so I flipped it over. This is the first part that we did. I flipped it over and shaved this edge. This is perfectly smooth and clean. Now I'm going to set up the automatic feature to automatically go along here and shave a little bit of metal off so it all gets shiny and a little bit thinner in diameter. And it's the first time I'll be using the automatic feed features. Look, Ma, no hands. So we've just completely shaved this rough, ugly metal out here to this lovely smooth finish here. Completely smooth. And it's all been done automatically. The nice thing about automatic, instead of doing it by hand, is that it moves at a steady pace, so you get a smoother finish than if it would be wound, and if it were. This is a different setup now. I'm driving by hand this top wheel, and this is going to push the bit in at I've changed things around, so it's going to push the bit at an angle and shave off a bevel on the inside of that. see how that looks. I'm gonna shave just the inside edge there.